Assalamualaikum and hi everyone. We are finally students from University Teknologi Mara Cawangan Negeri Sembilan, Campus Remban 3. Today, my group members and I will be representing a study entitled Forecasting and Unemployment Rate in Malaysia. The group members conducting this study is me, Nur Balkis binti On.
Me, Nur Alia binti Azhar.
Me, Wan Nura Adila binti Wan Abdul Razak.
Our supervisor is Puan Siti Sarah binti Januri, a lecturer from Faculty Mathematics and Science Computer in UiTM Remban 3. Unemployed refers to those who do not have a job but are interested in working. Based on CHAPLO 2019, unemployment may occur when a person who is looking for a job actively or inactively is still unable to get the job. In this era of modernization and innovation, employers are looking for a flexible employee who can help the organization to survive in the sector effectively, said Abdul Manaf, Hamid and Islam. Thus, the unstable unemployment rate indicates that the issue of the unemployment remains unsolved among the people in Malaysia. The figure shows the unemployment rate in Malaysia from year 1999 to 2019. Focused in year 2019, the unemployment rate increased from 3.36% in year 2018 to 3.4% by 0.04%. However, it is expected to be increased in this year due to the pandemic COVID-19, where it affects the economic growth worldwide. Unemployment is one of the biggest problems in Malaysia. Based on a report of Labour Force Statistics Malaysia in March 2020, the unemployment rate increased from 3.3% in February 2020 to 3.9% in March 2020 by 6%. It is reported that the unemployment rate in March 2020 is the highest in a decade since most of people are affected due to the COVID-19 and Movement Control Order (MCO). Based on the Chief Statistician of Department of Statistics Malaysia, Datuk Seri Dr. Muhammad Uzair Mahidin, said that within a month, the number of unemployed persons increased from 525,200 to 610,500. The movement control order due to the COVID-19 give a huge impact, especially on Malaysia economy. Increasing unemployment would not go well for private consumption, which contribute for almost 60% of the Malaysia's GDP. Hence, this has become the major concern for the workers. The objective in this study are first to identify the pattern of the unemployment rate in Malaysia along 10 years data series from January 2010 to December 2019. Second, to compare the forecasting performances of different ARIMA and STAR model using a MAPE and RMSE. And third, to forecast the unemployment rate using the BAS models.
Next, I'm going to explain about the methodology. The method that we use for this study is time series analysis. In this study, we use ARIMA and STAR models to forecast the unemployment rate in Malaysia. ARIMA model is a method of time series data that is proposed by Box and Jenkins in 1976, while STAR model is a continuity of autoregressive, which is AR, model through a regime switching, and it is a time series with a nonlinear pattern of threshold autoregressions first proposed by Tong in 1978. This is the result of ARIMA model that we obtained from this study. Figure 4.1 shows the time series plot of unemployment rate from January 2010 until December 2019. This step was to identify the pattern of unemployment rate along 10 years data series to fulfill our first objective. Based on the plot, there are no pattern indicates that the series is not stationary. Figure 4.2 shows the estimated value for the lambda is 5. Since the rounded value of lambda is 5, then transformation is needed. Figure 4.3 shows the transformation is performed on the unemployment rate data using Box-Cox transformation. Hence, no another transformation is performed since rounded value for the lambda is 1. This transformation is considered normally distributed and constant variance. Next, autocorrelation ACF and partial autocorrelation PACF were plotted to check the stationarity. while figure 4.5 shows that almost each pattern of PACF is not noticeable, and we can see 4 values that exceed the significant limit. Hence, it can be concluded that the series is not yet stationary. Next, since the data series is not yet stationary, first differencing was performed to make the data series become stationary. After first differencing was done, as we can see in figure 4.6, shows a trend that indicates the series is stationary. Therefore, D is 1. After we identify types of differencing, the next step is we perform AR and MA model. Figure 4.7 shows there are significant lags at 1, 9, and 10 of ACF, which indicate that a moving average is 3. While PACF plot in figure 4.8, on the other hand, shows lag of 1, 2, and 9. Hence, the proposed AR is 3. Based on figure 4.7 and 4.8, table 4.1 shows 4 possible models were identified and estimated, which are ARIMA 313, ARIMA 310, ARIMA 311, and ARIMA 312. In order to find the best models, we check the p-value and compare the p-value for all models. Therefore, ARIMA 312 is the best models for ARIMA because all the p-value is smaller than alpha 0.05.
Serta result. The first step in modeling the Serta model is to determine the order of autoregressive ARP from the partial autocorrelation function, and it is important to identify the existence of nonlinear threshold. An autoregressive order is chosen based on the significant spike at lapse from the graph partial autocorrelation function PACF. So, figure 4.9 shows that the PAC functions is significant at lag 1, 2, 3, and 10. The result of TC test for threshold nonlinearity on each autoregressive order is represented in table 4.2. TC test probability value larger than 0.05 indicate there is sufficient evidence to accept the null hypothesis of no nonlinear threshold in autoregressive order 1, 2, 3, and 5. As a result, the order of 4, 5, 6, 7, 8, 9, and 10 are reckonable to model the unemployment rate as compared to simple AR. From table 4.3, the AR order of 4, 6, 7, and 9 cannot be chosen due to the Jacobera test are rejecting null hypothesis, which residuals are normally distributed, since p-value of each autoregressive respectively are less than 0.05. So, assumption is violated. Table 4.4 shows some square of residuals, which selecting AR model from either AR8 or AR10 is based on the sum of square residual, which is the smaller value selected. The appropriate model chosen was AR10, since it has the lowest SSR value. Model forecasting performance of ARIMA and Serta model. The forecasting performance of ARIMA 312 and Serta 210-4 is compared on the basis of two measurements such as RMSE and MAPE in the model evaluations. Table 4.5 depicts that value error measure of Serta model is lower compared to ARIMA model, thus it is chosen for in-model estimation and in-sample forecasting from 2010 to June 2017. However, the outsample forecasting performance for model evaluation was found, since it is more trustworthy to evaluate the model for forecasting year 2020 ahead. From table 4.6 below, Serta model is the best model for forecasting unemployment in 2020 as it has the lowest RMSE and MAPE value. Since the model is chosen as the best model to forecast the year 2020, observe that the unemployment rate from January 2020 to December 2020 tend to vary from time to time and sometimes rise and sometimes falls consistently around 3.2%, as shown in table 4.7. However, the forecast result from February 2020 and March 20, which are 3.27% and 3.28 respectively, are obviously different from the real data with 3.9% and 6%. This may cause from the economic regression due to the pandemic COVID-19.
As a conclusion, predicting unemployment rate is one of the most important applications to capture the trend of unemployment issue and for the economic system. Fortunately, unemployment in Malaysia has not been categorized as alarming, but the government must remain obligated to find the appropriate measure to address the problem. For further result has been recommended. The first one is the data was limited to 2010 until 2019, where the irregular pattern trend not included in data series. The data on irregular trend should be determined to confirm the result in forecasting the unemployment rate. The second one is the present study deals with the unemployment rate in Malaysia. It is essential to consider the other variables to be included in forecasting the unemployment rate, such as working sector. The last one is one of the challenges is unpredictable environment, such as COVID-19 cases, which expose the effects in the results. It is suggested to consider the other methods that can cater the unpredictable behavior.
That's all from us. Thank you.